Hi guys. So I'm going to show you how to calculate the level term premium from a single pay premium. So I'm actually going to show you the whole entire thing because there's some stuff here that's shown incorrectly on YouTube, and I don't believe the level pay per year calculation is shown at all on YouTube, at least in Excel. Um, the actuarial formulas are very hard to read because there's all kinds of Greek symbols there. And even if you learn what those symbols mean, it's very hard to keep track of what the logic is supposed to be. If you just follow a scenario and you do it on paper or you do it in Excel, you can sort of label things better. You can follow where things are moving. So let's start here. So first of all, you have to get a mortality table. This one I pulled from the internet, Society of Actuaries. I think it's the .org, and I think this was like the ultimate risk table or something. And I pulled it off the internet. I just downloaded it. I think I copy pasted it. And what this is these are the ages, and this is the term, sort of. This is if someone is aged 12, so the first year of when they're 12. I'm not 100% sure, but I'm pretty sure that this cell here, the first row of 12, is when they're 12. So they have a zero mortality, then second year, third year, fourth year, fifth year, they have a this percent, they have a 0.072% mortality rate. Then the next year they have a 0.083% mortality rate. And this is not this is just plain mortality without calculating for survival for the previous years. So we're gonna get into that later. It's gonna get a little bit complicated because we're gonna sort of do what I call a cumulative compound survivability. So it looks more interesting when you get to like older, or I guess it's more relevant. Someone buys a policy when they're 30, so the first year mortality is 0.03%, then it's 0.046, and so on and so forth. And there's only, you can see with the count or by the rows, there's only 25 columns here. So what happens when we have a term longer than 25 years? Now, this may not be technically correct, but what I've told Excel to do is after 26th year, look at the bottom of the next one over. But we'll get to that soon. So first, I just want to establish we have our agent policy issue. And I'm going to we're going to assume for simplicity's sake, we don't have any off by one errors. We're going to say that the first year of the term is the age policy issue. We're not going to say in year zero or the first year is age plus one. Like you could get messed up all like this. I mean, each carrier or whatever probably has a different way they calculate it. They're welcome to whatever they want. I just made it easier for myself. And you have a term here. You have your discount rate, and your discount rate, you can put any rate you want. It's typically, I mean, it's gonna be for the insurer. It's really the carrier, the discount rate. It's gonna be their average performance, investment performance, probably. They might have a little bit of a spread, meaning they might charge a lower discount rate. They might use a lower discount rate than the actual um, asset performance in order that they have a investment profit to offset any underwriting losses. But that's a little bit more out of the scope of this video. So that's So discount rate, I'm just gonna assume it's 3%. Doesn't make a difference for the sake of this video. And 3% is a pretty good short term or treasury rate. I mean, depending on 2020 or 2020. one, whatever it is. I mean, it went up to 5. Now it's about 3.5 or something like that, right? It was down at 1 or zero point 0.5 during the Obama years. So, and then loading. We'll get to loading soon, but loading is basically the number that the carrier decides to add to that size that they add to the pure cost of insurance to pay for profit margin, to pay for admin expenses, and to pay commission. So loading is how they actually make money. Because theoretically, and it's not technically, theoretically, um, if they have 100% efficient mortality tables and 100% efficient discount rate, then the pure cost of insurance, the APV, the actual present value of the or the expected value of the payout will be 100% paid for. So how do they so it's just basically is a zero. It's a zero to zero. How do they make money? That's the loading. And because it's not 100% efficient, so they're gonna overcharge it. They might strategize decide to overcharge a little bit by with them to overestimate their mortality or to underestimate the rate um to in order to get the in order to get the premium higher, or they might actually strategize the other way, that they'll rely on their investment for performance. That they use a wider spread between the discount rate and their long rate, their investment performance rate. And yeah, that's really doesn't really have to do with, it's not necessarily connected to loading, but fine. Okay. Before we get to the meat and potatoes of the formulas, so how do you get to premium? Get to premium, you have to um take the death benefit. This is term insurance, right? Take the death benefit. You have 20 years over which this is going to be paid. I have 30 years because I can such make this up to 30. We have 20 years. Each year has its own probability, which is why we have to count them all. And besides each year's probability of death, you have to also discount to the present. So the first year, so for simplicity's sake, we're just going to go into this formula here to get moving. We're going to say, so but after all the if stuff, the if is just making sure that we're not past the term limit. That's why these are blanks, because the if evaluated the true, which is after the term. But what does the operating part of this formula show? It's your our payout divided by, and this divided by garbage. This is our discount factor. What is it? How do we translate this to English? So 1 plus our discount rate, because we have to divide by 1 plus. Because if you divide just by the rate, then you're essentially then you because when you grow your money, you're not growing by the rate, you're going by 1 plus the rate. So to discount, we have to divide by 1 plus the rate. That's basic present value, future value math. And then we're not just doing it once, we're going to raise this to the power, because we want to do this, compound it over the years. For the first year, we're not actually going to multiply it, discount it at all. So that how do we get the at all? We get it by using a dynamic reference to the row. So row 1 minus 1 is 0. Anything to the power of 0 is 1, regardless of this plus 1. So the whole base, anything base x to the power of 0 is just 1, not x. So, but the second year is, I'll get to the G10 in a second. Is here we get, well, 2 minus 1 is 1. This, the power of 1 is itself. And the power of 2 is 1 plus b times 1 plus b, and so on and so forth. I'm assuming you know how exponents work. The goal of this video is to explain the more in-depth math and the formulas. I'm assuming you already understand how present value works and how exponents work and so on. Okay. So what's this G over here? This is the mortality. In which to get the mortality, again, I have this if statement because I only want to fill out rows that are within the term, right? So this is the actual stuff here. Actually, the middle one is the simplest, right? Once you say if is correct, right? Because afterwards is 0. If is correct, I need to use index match formula to pull in pull the correct number from our mortality table. How do we do this? So this is our range, our mortality range. Which row are we gonna get? The row, so we're working sort of backwards because our age is in the column and our year of term is in the rows. But in the array formula, the row is first. So we need to find out how many years we're into our term. So that's why we're going to use the dynamic row formula, E1. It could be any column, doesn't make a difference. But the thing is, because as I said when I was initially showing you the table, because our mortality table is limited to 25 years, we need to bump it after 25 years, we need to bump it to the right. So how do I get it to stop dropping the row number though? That's where the min formula comes in. So right here, our row number is the minimum of whatever is less of 25, the number 25 and a row. So if our row is less than 25, because we haven't gone to the 26th year, it will show us the row. If our row is 26 or greater, the formula will return 25. So this will stop us at row 25. I have a +1 here because simply our table starts on row 2. So we have this is row, it's just 1 + 1 equals 2. Um let me yeah, and our range starts on A2. A2 includes the header, so that's why I have to bump it down by 1. That's kind of I could have just done without the header, but whatever. Okay, that's a row, and then our column is our starting age. So I need to pick up view 1. I don't know why it took the sheet name if it's well, on the sheet. When you go to a different sheet in your formula here, then when you go back to your original one, it puts the address of the entire sheet. I don't know. I think it's unnecessary. Whatever. Fine. Just to make it easier for you to read. So we need V1 is our age at policy issue, which is going to be solid reference. Um, right? And then we need to add because we said I need to bump over to the next column if we go more than 25 years. So this is just right the year, fine. And then we have to do the max of 0. So if we're not moving anywhere, fine, right? But if we're greater than 25, we need to subtract 25 from our row. So if we are 25 or less, then this will turn up a negative number. This will be less than 0, will return 0. If we are 26, this will return a 1, which is greater than 0, and the max will turn a 1, right? That's the math, how that works. Then we have a +1, I believe it's because our table, our reference is at A, but A is age 0, so we need to bump up 1 to start at age 1. I mean, yeah, if someone is 10 years old, they're living in their 11th year, right? So that's why this table is indexed at index 0. That's how that works. So this is the so-called simple table, right? This is just pulling the mortality of that year, right? So this column right here, starting at 39, is age 25, starting at 39, going down for 20 rows, right? Ending at 2, 1, 1, ending at 211, right? That's that. Next, next, this, so that's the simple mortality. But the problem is for for a um for the to know if you are holding at year zero, if you're starting from the beginning and we didn't move from year zero to year one yet, then the probability of death in year two is not just the mortality of year two, it's the mortality of year two times the probability that you already survived year one. So the survival of year one is one minus the mortality, right? So let's go over this. Survival at year zero is one because you're there, you're alive now, right? So you're 100% alive. There's no way you're gonna die now because you're here. You haven't already died yet. Okay, that's your mortality during that year. Mortality from year zero is the same number because we're multiplying the survival. You are now here. You are here. 100%. You are now here. So therefore, one times the mortality is the mortality, right? So the only thing we changed from column F to column G is we added this multiplier, multiplying by the survival of the past years. So where it starts getting complicated is where we start compounding. So what happens now? Survival, again, this highlighted cell is just the if statement again. Actual thing of it is very simple. It's just the past survival minus times one minus the mortality. So survival, this number is the survival of before times one minus this mortality gives us the survival of that year. Surviving this year is this number. And then this, again, mortality of year two is not just the mortality of the year of it by in and of itself. Mortality of year two from the point of view of year zero, right after the header, is now survival to year two times the current times the mortality. And I could have just done a cell reference here to here instead of using the whole thing. In fact, I'll prove it to you. I don't have to have all that garbage there. I could have just done this. It's the same exact number. And I'll double click it down and nothing changed. It's just easier to read the formula now. Right? Again, the if statement is just making sure we're in our term year limit. Then we have survival of the past year times the mortality of this year is the mortality of this year from the point of view of year zero. So and just to go one more row just to see how it flows. Survival of last year, survival to this year is the survival of the past years times one minus this. And this number here is not the survival through this whole year. This number is a survival of the past. This number is a survival of the past, or survival to up to this year. So again, this is the survival to up to the past year times one minus the mortality. So one minus the mortality of the past year is the survival of the past year in and of itself. It's not really in and of itself because we said mortality from year zero. Hopefully, that doesn't sound too circular to you because this is, like I said, cumulatively compounding. We haven't, this is completely, the compounding that I'm talking about here is completely not connected to the compounding of present value. I mean, it's compounding because of this, because it's the same years. And it's also it's multiplication, but it's nothing to do with investment. It's to do with probability. Okay, so now we have mortality from the point of view of year zero. The reason why we need of year zero and not of each year is because we are standing at policy issue, and we want to know what the mortality from our point of view is at that year. So let's go back to this formula, right? We have to, again, it's the payout discounted to the present times the mortality gives you a much smaller number than the payout. Just run through it again. This number. So I'm just so far we haven't touched level pay. We're calculating, we're building up to the single pay premium. The payout discounted, again, 1 plus the rate to the power of the current year minus 1 gives us, so this is 2 minus 1 gives us 1. Power of 1 is 1 times, is just multiplying, dividing it by this once times the mortality. The next year is payout discounted by our rate. The power of 3 minus 1 is 2. So to the power of 2. So we're dividing that by this essentially twice, or this times itself and then dividing by it, then multiplying by our mortality. Okay, hopefully that makes sense. So now we have all of our discounted payouts multiplied by mortality. What do we do with all these numbers? The sum of all these numbers is our unloaded premium. Again, I don't have to discount, even though it looks like a schedule or a column of numbers. Each number is discounted to the present. So these are all in today's dollars. The reason why the numbers go up and not down, even though they're discounted, is because our mortality is rising faster than our discount rate can discount. If we raise our discount rate to 8%, you'll see that this number floats a little bit because our mortality is acceleration is not smooth. Our discount rate is smooth. So we go up, we go down, we go down, 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 we go up, 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 right? I don't know why, but the actuaries figured out the numbers that at year 20, let's go to year 30 and see if it's smoother. If you go to, right? So here we see that from 30 years old, even with the discount rate of 8%, the mortality rises. I guess with the last year here, it goes down a bit, or it's fine. It's pretty variable. That's not the point. I just wanted to, if you were confused as to why the numbers were going up and not down, even though we're discounting, is because the mortality is rising. Okay, so now we have the premium, right? This is unloaded premium, the pure cost of insurance, and then we multiply by 1 plus our load. Again, if you just multiply by our load, you're going to get a fraction. You want to do 1 plus our load, right? That's how you get single premium. Now, the next part is a little bit more it's not more complicated. It's just more complicated steps to get how to get level pay. The level pay is not just dividing your premium, your single pay premium, by the number of years in your term. You think that would be what it is, right? But it isn't. If I take divided by 20, you get a much lower number. And you probably think why that is intuitively, because we don't know that the guy's going to survive until each year. He's not going to see the hope. He's buying it because he thinks he might die before it gets to those years. So we have to price in the fact that he might die before he gets to pay those years. So what do we do? How do we get it? We take our unloaded premium. That's our cost of it. That's our expected, the present value of expected future benefits. That's the official language for that, right? Now we divide it by this humongous thing over here. If you look online, you're going to see it's sum of future expected benefits divided by the is there now we're gonna have there's two things. Basically, some product formula, you know how it is two arrays. So we have one array here and one array there. So the one array is our surprise is our survival, right? Because we basically want to say what is the survival probability of each year's payment happening. We're not asking what is the survival rate for him to get it. We're asking what is the survival rate for him to pay it, right? And then the second array, because we're multiplying two arrays, one array by the other array. One array is the survival at to get to each year. Survival year one is one, survival year two is not one, right? And so on and so forth. Second array is the discount rate. Now we're not multiplying anything by our discount rate. We're just doing the discount rate itself, right? So how would you get the point? This weird little thing here is we're telling this is the math to tell Excel I want the discount rate for year one, year two, year three, year four, year five in an array. Discount rate of year one is not three. It's essentially zero. It's we're just multiplying or dividing by one. And year two is 3%. Year two is 3 times 3 or 3% times 3%, but it's not. It's 1 plus. So that's why we have this thing. We have 1. So if you do 1 divided by 1, you would get 1. 1 divided by, right? So the first year is supposed to be 1. So 1 plus B3 is our discount rate. I don't have to put the absolute reference because it's just this is one cell. 1 plus our rate gives us a growth rate. So we're not just a 1 percentage. We need 1 plus the percentage to be able to multiply and divide by it. And then our exponent is where we force Excel to. We're not brute forcing anything. We're just telling Excel to make an array because this is an array. We need an array. So what's the array? It's just the number 1. When you want 30, we want 30 numbers in our array. And it doesn't matter the fact that it's 30 even though we have term of 20, because you'll see here the survival probability is forced to 0 because of the if statement in these formulas. So we're gonna have a third, no matter what the term is, I'm calculating 30 a 30 array by a 30 array, but the unfilled parts of both arrays are just gonna multiply to 0. So it doesn't matter. So we have 30 pieces in our array, one column, and start is 0. So let me just show you what this would look like outside of a formula, right? So I was confused actually myself. The default step or the default progression of the sequence formula is the number is just 1. So if I start by 0 and then the default step is 1. So I can actually delete this. Well, okay, delete that. Okay. Just wanted to show you what it looks like. So we have basically from 0 to 30 minus 1. And I'm not worried about the trailing after 20 because, or really 19, because we're starting index 0, because we already have zeros here. So this gives us, if you want to see what this looks like in an array, I can show you here. Yes. So this is called the annuity factor. I can show you that this is what we are dividing our premium by, single pay premium by, basically 15. I want to show you what this number is. This array is 1. So the first year's discount is 1. The second year discount is 0.97. So the discount factor is sort of 1 minus your discount rate. And then the second year is 1 minus your discount rate. Essentially, that's what this formula gives us. Because we're multiplying, we're dividing by it, so it's essentially what we're multiplying by. It's hard to say. Um, that's what gives us our level pay. And this here is just the same thing. This is again loaded. So I could either load this number or we can divide this number by the same exact formula. Hopefully, that makes sense to you. I believe this is the only Excel video, only video on Excel explaining in Excel and simplest language how you get level pay from single pay, because all the stuff, the other videos are actuarial notation or incorrect. Um, by the way, I'm gonna post a link to my website, Kellam Life LLC, um, where a completely different product or policy is showcased. Um, I'm not showing you how I built that. I'm showing you how you would build the product that I'm basing my product off of. If that makes sense. My product is called Decreasing Term Scheduled Benefits, and it's using this as a industry standard. All right. Thank you and good night.